Hello, this is Dr. Mears. Today we're going to learn about geometric sequences. Make sure you have the worksheet labeled Video Geometric Sequences. The directions state determine if the sequence is geometric. If it is, do the following. 1. Write the next term. 2. Write the common ratio. And 3. Write the explicit rule. So here we go. We have to find how to get from one number to the next by multiplying. So from 3 to 12, I'm going to multiply by 4. From 4 to 48, I also multiply by 4. And from 48 to 192, checking in my calculator, that's also times 4. So this is geometric, so I'm going to write down yes. Multiplying 192 times 4, 192 times 4, that's 8. This is 6, carry the 3, so that's 768. 768 would be our next one. Next, we have to find the common ratio. Well, that's easy. We're just multiplying by 4, so R for common ratio is 4. Our explicit rule I'm going to write down as we did in our ISN, a sub n equals a sub 1, our first term, times our ratio to the n minus 1 power. Let's substitute in our numbers. A sub 1 is 3, that's our first term right here, times our common ratio is 4 to the n minus 1, and that's it. There is no simplification like in our arithmetic sequences. That's the explicit rule. Number 2, how do we get from 2 to negative 12? We're going to multiply by negative 6. Ooh, now it's a negative, so be careful. From negative 12 to positive 72 is another negative 6 times negative 6. And from 72 to negative 432, that's another negative 6. And now what gives this negative away is that you're switching between positive and negative. So if you see positive, negative, positive, negative, positive, negative, and it goes back and forth, you're probably going to be multiplying by a negative number. So we have to find the next one. So we're going to have to do some definite multiplication, negative 432 times negative 6. And that's going to give us a positive 2,592. So yes, it is geometric. Here is our next term. We can go and now find our common ratio, which was negative 6. And our explicit rule, a sub n equals a sub 1 times r to the n minus 1. Substituting our first term, a sub 1, which is 2, times, and now I'm going to put parentheses around this negative 6 just to hold it together with that negative sign, and then the n minus 1 up top. That's it. That's our explicit rule. Let's go to this last one. We have negative 4, negative 20, negative 100, and positive 400. So we're going back and forth between negative, positive. So this is probably going to be definitely multiplied by a negative number, and it's true because negative 4 times negative 5 gives us 20. Let's do it again. 20 times negative 5 does give us a negative 100. Now, here's my advice. Don't just stop here. You're like, oh, it's negative 5. Do it one more time. Because I bet, let's make sure this is truly geometric and that if we multiply negative 100 times a negative 5, we should get 500. Well, let's look. What's this answer? This is 400. We would have to actually multiply by a negative 4 to get to 400. If it was geometric, that answer would have been 500. So as you notice, negative 5, negative 5, negative 4, this does not have a common ratio, therefore it is not geometric, and that's what we're going to write. This is Dr. Mears. This has been geometric sequences, determining if it is geometric, finding that next term, finding the common ratio, and writing the explicit rule. The first two were geometric, and the last one was not. I hope this helped. Thanks.